Our universe is a place of awe-inspiring vastness and complexity. From the smallest subatomic particles to the largest galaxies, the universe operates according to a delicate balance of laws and constants. These laws and constants determine everything from the formation of stars to the emergence of life. But what if these laws and constants were even slightly different? What if the universe as we know it is not an arbitrary accident, but a finely tuned system? The sheer improbability of our existence amidst the vast cosmic arena has intrigued scientists, philosophers, and theologians for centuries. How did our planet, with its life-sustaining conditions, come to be in this vast expanse of the cosmos? Is Earth a unique miracle, or are there countless other worlds teeming with life? These questions lie at the heart of one of the most profound scientific and philosophical inquiries. Is the universe fine-tuned for life? The quest to understand our place in the cosmos has led to the development of the Anthropic Principle, a set of ideas that explore the relationship between the universe and the existence of observers within it. The Anthropic Principle suggests that the very fact of our existence imposes constraints on the possible properties and values of the universe's fundamental parameters. In essence, it argues that we observe a universe fine-tuned for life because if it were not, we wouldn't be here to observe it. The Anthropic Principle is often illustrated using the analogy of the Goldilocks Principle. Just as Goldilocks found the porridge that was just right, our universe seems to possess a remarkable set of properties that are just right for life as we know it. These properties include the strengths of the fundamental forces, the masses of elementary particles, and the initial conditions of the Big Bang. If any of these parameters were even slightly different, the universe would be a vastly different place, likely inhospitable to life. For example, if the force of gravity was slightly stronger, stars would burn out much faster, leaving no time for life to evolve. If it was slightly weaker, stars might not ignite at all, leaving the universe cold and dark. This delicate balance extends to other fundamental constants as well. The electromagnetic force, responsible for binding atoms together, needs to be precisely tuned for stable atoms to form. The weak nuclear force, which governs radioactive decay, plays a crucial role in the nuclear reactions within stars, ultimately providing the energy necessary for life. The fine-tuning of these and other parameters has led many to believe that the universe is not simply a random assortment of physical laws and constants, but rather a system carefully calibrated for the emergence of life. This idea, while intriguing, is not without its critics and has sparked intense debate within the scientific community. The Anthropic Principle states that the universe's properties must be consistent with the existence of observers. Our existence places constraints on the universe's characteristics. This principle has profound implications for cosmology. It raises questions about the nature of the universe and our place within it. The seeds of the Anthropic Principle were sown long before it had a formal name. Early astronomers and philosophers noticed the seemingly special conditions of our existence. Epicurus proposed an infinite universe with infinite worlds. The Renaissance telescope revolutionized our cosmic understanding. Copernicus and Galileo proposed a heliocentric model. This shift fueled speculation about other worlds and life beyond Earth. Scientists began to appreciate the delicate balance necessary for life. The 20th century saw rapid scientific advancements in cosmology and particle physics. Discoveries like the expanding universe and the Big Bang theory revealed a complex, interdependent universe. In 1973, physicist Brandon Carter introduced the Anthropic Principle. He proposed that our observations are limited by the conditions necessary for our existence. This sparked both intrigue and controversy. Despite debates, Carter's work elevated the Anthropic Principle to serious scientific inquiry. Central to the Anthropic Principle is fine-tuning, where fundamental constants appear fine-tuned for life. If these parameters were different, the universe would be inhospitable. Gravity's strength is a prime example. Slightly stronger or weaker, stars wouldn't support life. This fine-tuning suggests a universe calibrated for life, sparking debate about our place in the cosmos. The Anthropic Principle, while offering a potential explanation for the fine-tuning of the universe, has also faced its share of criticism and alternative explanations. One of the most prominent counter-arguments to the Anthropic Principle is the concept of the multiverse. The idea that our universe is just one of many universes, each with its own set of physical laws and constants. The multiverse hypothesis, while still speculative, has gained traction in recent years as a way to explain the apparent fine-tuning of our universe without resorting to anthropic reasoning. According to this view, the universe we observe is simply one realization within a vast ensemble of universes, each with its own unique set of properties. Just as a lottery winner might marvel at their good fortune, we might simply be living in a universe lucky enough to have conditions suitable for life. The multiverse hypothesis, while intriguing, remains highly speculative and difficult to test empirically. However, it offers a potential way to reconcile the apparent fine-tuning of our universe with the absence of any obvious design or purpose. If the multiverse hypothesis proves correct, it would have profound implications for our understanding of the cosmos and our place within it. It would suggest that our universe is just one of countless universes, each with its own unique story to tell, a humbling thought that further emphasizes the vastness and wonder of the cosmos. In the vast expanse of the universe, certain physical constants play a crucial role in determining the structure and behavior of all matter and energy. These constants, numbers that remain unchanged across the observable cosmos, are fundamental to the laws of physics. Examples include the speed of light, the gravitational constant, and the strengths of the electromagnetic and nuclear forces. Alter any one of them even slightly, and the universe as we know it would not exist. The precise tuning of these constants suggests a universe finely adjusted to support life. Gravity, one of the four fundamental forces, shapes the universe. It pulls matter together, forming celestial bodies and governing their interactions. The gravitational constant, g, determines gravity's strength. A slightly larger g would shorten star lifespans. A smaller g might prevent star ignition. Gravity's fine-tuning affects the universe's structure and planetary systems. This balance is crucial for life to develop and thrive. Small changes in g have dramatic consequences, showing the universe's fine-tuning. Electromagnetic and nuclear forces are essential at atomic and subatomic levels. The electromagnetic force governs the behavior of atoms and molecules. It is crucial for the formation of chemical bonds. The fine structure constant determines the strength of electromagnetic interactions. The strong nuclear force binds protons and neutrons in the nucleus. The weak nuclear force governs radioactive decay and nuclear fusion. These forces must be precisely calibrated for the formation of atoms, molecules, and life. The cosmological constant, denoted by lambda, represents the energy density of empty space or dark energy. It influences the universe's expansion rate. A larger lambda would prevent galaxy formation. A smaller or negative lambda could cause collapse. The observed value allows for life. This fine-tuning is a major puzzle in cosmology. The universe's initial conditions, set at the moment of the Big Bang, play a crucial role in its evolution. These conditions include the distribution of matter and energy, the overall density, and the initial rate of expansion. The fine-tuning of these initial conditions is crucial for the universe's suitability for life. One key parameter is the density of matter in the early universe. If the density were too high, the universe would have collapsed under its own gravity. If it were too low, the universe would have expanded too quickly for galaxies to form. The observed density is close to the critical density required for a flat universe. Another critical aspect is the degree of uniformity in the early universe. Observations of the cosmic microwave background reveal tiny fluctuations in temperature and density. These fluctuations are essential for the formation of galaxies and large-scale structures. If the universe were perfectly uniform, structures like galaxies and stars would not have formed. The initial rate of expansion, governed by the inflationary epoch, also plays a vital role. Inflation theory suggests that rapid expansion smoothed out irregularities, leading to the uniform universe we observe today. The fine-tuning of the inflationary parameters is crucial for a life-supporting universe. The precise initial conditions of the Big Bang add to the evidence of fine-tuning. These conditions needed to be just right to allow for a universe capable of developing complex structures and life. The Anthropic Principle suggests we observe these conditions because in a different universe, observers like us would not exist. The fine-tuning of the universe's initial conditions, along with the fundamental constants and forces, presents a compelling case for the idea that the universe is finely tuned for life. Whether this fine-tuning is the result of a deeper underlying principle, the multiverse, or some other mechanism remains a topic of ongoing scientific and philosophical inquiry. The Anthropic Principle suggests a universe fine-tuned for our existence. Critics argue this might be an illusion. They propose selection bias as an explanation. Imagine a puddle marveling at its perfect fit in a hole. The shape is determined by the hole, not vice versa. Similarly, our existence shapes our perception of fine-tuning. We exist because the universe's conditions allow it. This doesn't imply the universe was fine-tuned for us. Critics advocate for exploring deeper physical principles. Instead of accepting fine-tuning, seek fundamental theories. Another counterargument to the Anthropic Principle stems from the perspective that our perception of fine-tuning might be a matter of human bias, an anthropocentric view that places undue importance on our kind of life. We tend to define fine-tuning based on the conditions necessary for life as we know it, carbon-based life that requires liquid water and a specific range of temperatures. However, this definition of life might be too narrow. The universe is vast and complex, and it's conceivable that other forms of life, completely different from us, could exist under drastically different conditions. These hypothetical life forms might find our universe, with its specific set of constants, to be perfectly ordinary or even unsuitable for their existence. The universe might not be fine-tuned for our kind of life, but it could be compatible with a wide range of life forms, each adapted to its own unique set of conditions. Our perception of fine-tuning, therefore, might simply reflect our limited understanding of the full spectrum of life's possibilities. Critics argue that we should be cautious about projecting our anthropocentric biases onto the universe. The universe might not be obligated to follow our rules or cater to our specific needs. Instead of searching for a universe fine-tuned for us, we should remain open to the possibility of a universe teeming with diverse forms of life, each with its own definition of just right. Our understanding of the universe, while constantly expanding, remains remarkably limited. We might be mistaking a small piece of a much larger puzzle for the complete picture. The apparent fine-tuning, based on our current knowledge of physics and cosmology, could simply be a consequence of our limited grasp of the universe's true nature and the fundamental laws that govern it. Imagine trying to decipher the rules of chess by observing only a small section of the board. We might deduce incorrect rules based on the limited pieces and moves within our view. Similarly, our current understanding of physics might be based on a limited set of observations within our cosmic neighborhood. We might be missing crucial pieces of the puzzle that could completely change our understanding of fine-tuning. For instance, string theory, a theoretical framework in physics that attempts to reconcile quantum mechanics and general relativity, proposes the existence of extraspatial dimensions beyond our perception. These extra dimensions, if they exist, could have a profound impact on our understanding of the universe and its fundamental constants. The apparent fine-tuning we observe might be a consequence of our limited perspective within a four-dimensional space-time. A more complete understanding of the universe, encompassing these extra dimensions and other unknown factors, might reveal that the constants we perceive as fine-tuned are not arbitrary, but emerge naturally from a more fundamental theory. Our definition of life, based on our understanding of terrestrial biology, might be too restrictive. We tend to focus on carbon-based life forms that require liquid water, a narrow range of temperatures, and specific chemical elements. However, the universe is vast and diverse, and it's conceivable that life could exist in forms we can barely imagine. What if life doesn't require water, but thrives in liquid methane or ammonia? What if it's not carbon-based but relies on silicon or other elements? What if it exists in environments with extreme temperatures, pressures, or radiation levels that we consider hostile? Our current understanding of life is based on a single data point: life on Earth. It's presumptuous to assume that this is the only way life can manifest. The universe might be teeming with life forms that defy our current definitions, existing in ways we haven't even begun to consider. If life can take on such diverse forms, then our perception of fine-tuning, based on our limited definition of life, might be fundamentally flawed. The universe might not be fine-tuned for our kind of life, but it could be teeming with life in its myriad forms, each adapted to its own unique set of conditions. The debate surrounding the Anthropic Principle highlights the limits of our current knowledge and the importance of continuous exploration and inquiry. While the Anthropic Principle offers a potential explanation for the apparent fine-tuning of the universe, it's crucial to acknowledge its limitations and consider alternative explanations. Instead of resorting to anthropic reasoning as a definitive answer, we should view it as a starting point, a catalyst for further investigation. The pursuit of a deeper understanding of the universe, its fundamental laws, and the origins of life should continue to drive scientific inquiry and inspire us to explore new frontiers of knowledge. The search for answers might lead us to discover new physical laws, uncover hidden dimensions, or encounter life in forms we never thought possible. The journey itself, the pursuit of knowledge and understanding, is just as important as the destination. As we continue to explore the vast and enigmatic universe, we might find that the most profound discoveries are not the answers we seek, but the questions they inspire. The Anthropic Principle sparks debates beyond science, touching philosophy and theology. The universe's constants seem tailor-made for our existence, raising profound questions. Is our existence a fortunate accident or a sign of deeper meaning? This fine-tuning suggests a cosmic purpose, alluring to many. It speaks to our desire for meaning and significance. This often leads to discussions about a creator or guiding intelligence. Attributing purpose to the universe is philosophically complex and contentious. Critics argue such arguments are flawed, relying on assumptions. The debate about our existence's purpose remains unresolved. It highlights the deep philosophical implications of the Anthropic Principle. We confront fundamental questions about our place in the cosmos. The multiverse hypothesis suggests our universe is one among many, each with unique physical laws. Imagine a cosmic lottery where we live in the universe with favorable conditions. This idea challenges the notion of a single, unique universe. It raises profound questions about the nature of reality. The Anthropic Principle, with its implications of fine-tuning and the possibility of a multiverse, inevitably leads to questions about purpose in the universe. If the universe is fine-tuned for our existence, does that imply a purpose behind it all? Or is the universe simply a vast, indifferent machine, operating according to impersonal laws, with no regard for our existence or our search for meaning? The search for purpose is a deeply human endeavor. We seek meaning in our lives, in our relationships, and in the world around us. It's natural to extend this search for purpose to the universe itself, to wonder if our existence has a cosmic significance. However, finding definitive answers to these questions has proven elusive. Some find solace in the belief that the universe was created with a purpose, that our lives have intrinsic meaning within a larger cosmic plan. Others find meaning in the very act of seeking knowledge and understanding, in unraveling the mysteries of the universe through scientific inquiry and philosophical exploration. Still, others embrace the idea of an indifferent universe, finding freedom and responsibility in the absence of a predetermined purpose. The Anthropic Principle, while not providing definitive answers, offers a framework for contemplating these profound questions. It encourages us to consider the nature of our existence, the vastness of the cosmos, and the possibility of other universes with their unique stories to tell. The Anthropic Principle, whether viewed as a profound insight or a philosophical distraction, highlights the enduring human quest to understand our place in the cosmos. It reminds us that we are part of something much larger than ourselves, a universe of awe-inspiring scale and complexity. While we may never have definitive answers to questions about fine-tuning, the multiverse, or the ultimate purpose of our existence, the very act of seeking these answers pushes the boundaries of human knowledge and deepens our appreciation for the wonders of the universe. The Anthropic Principle is not a final destination, but rather a starting point, a catalyst for further exploration and discovery. It encourages us to continue asking fundamental questions about the nature of the universe, the laws of physics, and the origins of life. It reminds us that the universe is full of mysteries, and our quest to unravel them is an ongoing journey of discovery. As we delve deeper into the realms of cosmology, physics, and philosophy, we may find that the most profound discoveries are not the answers we seek, but the new questions they inspire. The Anthropic Principle, with its inherent mystery and profound implications, will likely continue to intrigue, challenge, and inspire us as we continue our exploration of the universe and our place within its grand design. Our exploration of the Anthropic Principle spans from subatomic particles to the multiverse. It suggests a universe finely tuned for life, yet opens a Pandora's box of questions. The debate continues, enriching our quest for understanding. The Anthropic Principle serves as a poignant reminder of our deep connection to the universe. Our existence is intertwined with the fundamental laws of physics and the initial conditions of the Big Bang. As we stand at the precipice of new discoveries, we anticipate further insights into the universe. The search for life beyond Earth is now a vibrant field of scientific inquiry. The Anthropic Principle will continue to inspire generations, reminding us of our place in the cosmos.